Hello everyone. So kule video sizo discussa topic yama functions and graphs. So it will be a revision lesson. So into engizoyenza kule video is I'll go through the concepts involved kuma functions and graphs, and then afterwards sizokwenza ama questions. Right. Ngaphandle kokuthi simoshe isikhathi, let us get into it. So I'll just read through these notes, and then I'll do questions later on. I'll read through and try to explain and do questions. Right, so here they start by defining what a function is. So if you are given a set of x values, you can work out the set of y values or answers that came from using a given rule on each x value, right? So a function, we have our x values and we want to determine y values using some rule. That rule will be the function, right? So the relationship, so there is a relationship between the x values and the y values that is described by a rule. Usually a rule is in a form of an equation which represents the function. The x values are the input values and the y values are the output values. In the flow diagram below, the rule is y is equals to 2x minus 1. So for every x value, we multiply it by 2 and subtract 1 from it to find the corresponding y value, right? So in this flow diagram, we have a visualization of a function. So a function, we input x values to get y values. Notice that for each x value, there is only one corresponding y value. So this represents a function, right? Remember, a function, for every x value, there only has to be one y value, only one y value, otherwise it won't be a function, right? The input values or x values are the elements of the domain of this set, and the output values or y values are the elements of the range of this set. Now when you think about the domain, think about the x values, and then when you think about the range, think about the y values. In a Cartesian plane, when you think about a domain, think about the x-axis, and then when you think about the range, think about the y-axis, right? So so in this case, if maybe we draw a Cartesian plane, things are going to draw a straight in. Okay, if we draw a Cartesian plane, right, and then this is our y-axis, this will be our x-axis, right? It continues to infinity, right? This is our x-axis, right? So when we talk about the domain, we're talking about the x values which will lie in here. So when you think about the domain, think about the x-axis, and then when you think about the range, think about the y-axis, right? So yeah, if we visualize what's happening, this is what's happening. The domain is a set of x values and the range is a set of y values, right? So we can plot these points in a Cartesian plane to get the representation of a function in a graphical form, right? So if we extend the domain so that x is an element of the real numbers, we'll have the entire x-axis, and then we can get the graph for y is equals to 2x minus 1. Okay, so as is Kubega, we will get to a section last sketch a conic graph given a function, right? So looking at the graph, for every x value on this graph, there is only one y value, right? for every x value there is only one y value. Let me try to show you ukuthi sichaza ukuthini. Okay, for every x value there only has to be one y value. Okay, so this is one x value. When x is equals to 1, the corresponding y value is also 1, right? Therefore we have a function. Again, when x is equals to 2, the corresponding y value is 3. We have a function, right? In a case where maybe you have, let's say, a graph that looks like this, a graph that looks like this, notice for this x value here, we will get this y value, which is here, and we will also get this y value, which is here, right? So for one x value we are getting two y values. Therefore this graph is not a representation of a function. This is not a function. And then as isiqhubeka we'll see ukuthi it fails the vertical line test because it cuts in two parts of the graph, right? Yeah, so this is a function because for every x value there's only one y value, right? A function is a relationship between x and y where for every x value there is only one y value. One way to decide whether or not a graph represents a function is to use the vertical line test. If any line drawn parallel to the y-axis, the graph, if any line drawn parallel to the x-axis cuts the graph only once, then the graph represents a function, right? Like in these pictures here, graph A, notice that dotted line drawn parallel to the x-axis, to the y-axis, cuts the graph only here, right? So it cuts the graph at only this point. Therefore this is the representation of a function. Again, graph B, the vertical line test, that dotted line, it cuts the graph only at one point. Therefore this is the representation of a function. But notice lapha graph C, this line cuts the graph at 2 points, right? Therefore it means for this x value we are getting two y values. Therefore this is not the representation of a function because this definition, it doesn't hold, right? A definition of a function is that for every x value a function is a relationship between x and y, where for every x value there only has to be one y value. So in this case, for this one x value we are getting two y values. This is not a function, right? I hope that makes sense. Okay, and then discussing function notation, right? We use this function notation f at x to show that each y value is a function of an x value, right? Meaning if we substitute an x value, we are supposed to get only one y value, right? We can also use other letters such as G and H, right? So y equals to 2x minus 1 can be written as f at x is equals to 2x minus 1, right? So let us do activity 1. Sizame u understand the notation my functions, right? Okay, this is just an introduction, guys. I know it's maybe for some of you it's too straightforward, but then ngifuna ukuthi sonke si understand ama concepts bese later on ngizonikhombisa ukuthi how do we apply them in exam questions, right? So lapha ku question 1 bathi if h at x is equals to 1 over 2 to the power x, determine the value of h of minus 4, h at minus 4, right? So if h at x is equals to 1 over 2 to the power x, then h at minus 4 will be 1 over 2, and then where we see x we put minus 4, right? This will be 1 over 2 to the power minus 4, which will be 2 to the power 4, which will be 16, right? So the way to interpret this is when x is equals to minus 4, then y is equals to 16, right? Then this is a function, because for one x value we are getting one y value, right? And then nasiya question 2, but if g of x is equals to minus x squared minus 3x, what is g at x plus h, right? So wherever we see x in the original function g at x, we put x plus h, right? So la ngibona x so substitute x plus h, right? And then after into ngizoyenza expand this expression, right? So here I will have x squared plus 2xh plus h squared, and then here I will have minus 3x minus 3h, right? And then final answer will be minus x squared minus 2xh minus h squared minus 3x minus 3h. Therefore, the way to interpret this is to say when x is equals to x plus h, then y is equals to this expression. Enye into kumele we understand ukuthi if we have a graph, if we draw maybe a graph of this function, when we are saying x plus h, we are transforming or doing something to the original function. In this case, when we're saying we're substituting x plus h, we are simply shifting the graph of this function g of x by x units horizontally, by x plus h units horizontally, either to the left or to the right. Okay, I think I'm going to explain now, right? Let's say we have a graph like this, right? This is a parabola, and then let's say this is the graph of f, right? Where f of x is equals to x squared, right? And then mangioti f of x plus 2, then into ezoyenzeka lapha is ukuthi I will shift this graph 2 units to the left horizontally, right? So igraph lena izoza la, right? Sorry. So igraph le izoza la, right? And then f of x plus 2, wherever I see x in that function, I'll put x plus 2, right? Plus, is it 2x plus 4? Sorry, this is 4x, x plus 2, x plus 2, x squared. This is 4x plus 4. 4x plus 4. So we are shifting the graph of f 2 units to the right. Yeah, into ngizama uyichaza ngileyo ukuthi whenever we are sort of substituting here, if we have a graph of the original function, when we are doing this, we are sort of transforming the graph of the original function. We are shifting it in a way. I hope that makes sense. Going on to question 3. Question 3. Question 3.1. If f of x is equals to 4x plus 1, determine the value of f of x plus a. Again, this is a horizontal shift by a units. We are shifting the graph of f a units horizontally, either to the left or to the right, depending on the value of a. So f of x plus a, wherever I see x, I put x plus a. Right? 4x plus 4a plus 1. Right? I know this is straightforward, but then as a revision, as part of our revision, we have to do it. And then 3.2, f of x plus a. In this case, here we are shifting. 3.1, we are shifting the graph of f of x a units by a units by a units horizontally, right? And then here we are shifting the graph of f by a units vertically, either up or down. Here 3.1, we are either shifting it to the left or to the right, right? So 3.2, f of x plus a is simply f of x plus 1 plus a. 3.3, 3.3, a times f of x, right? Here we are also transforming the graph of f. Depending on the value of a, we are either shrinking the graph of f or we are sort of expanding it, right? So if the graph of f is a parabola which looks like this, and then a is less than 1, and then when a is less than 1, when we are multiplying by a, we will be shrinking this graph, right? We will be shrinking the graph to sort of like shrink. When a is greater than 1, we will expand the graph, right? Yeah, this is a transformation again. So a times f of x will be a times 4x plus 1 will be 4xa plus a. Okay, and then question 4. Question 4, we have g of x is equals to 2x squared, and then we want to determine g of minus x, right? This is another transformation to the graph of g, right? When we are saying g of minus x, we are simply reflecting the graph of g about the x, about the y-axis, sorry. So if for argument's sake, let us say the graph of g looks like this, this is the graph of G, right? G of X, right? And then G of minus X will be a reflection of this graph about the y-axis, right? This will be the reflection. This is the original graph, right? So wherever I see X, I put minus X. Which will bring us back to the original function, right? So a graph G will look like this. It's a parabola which looks like this, right? When you are reflecting this graph about the y-axis, you will get the original graph, because when you are reflecting, this point will come here and then this point will come here. You are sort of like in the same position. So which is why when we are substituting by minus X, we are still getting the original function, right? And then 4.2, we are saying minus G of X is equals to minus 2x squared. This is a reflection of the graph of G about the x-axis. So if this is the graph of G, the graph of minus G of X will be like this, right? We are reflecting it about the x-axis. So if this point is here, it will come down, and then if this point is there, it will come down, right? A reflection is sort of like a mirror image of the original graph. So if we are saying minus G of X, it's the mirror image using this line. Using this line, the x-axis as the mirror. And then if we are saying G of minus X, we are using the y-axis as our mirror. Okay, I hope that makes sense. So into engizama ukuyichaza with these drawings ukuthi uzama uku-understand ukuthi what is happening here kule question le. This question is very straightforward to answer, but into ebalulekile ukuthi are you able to interpret what is happening here, right? You must be able to interpret ukuthi kwenzekani la, right? So nasicala lapha ku 3.1 ngithe this part is a horizontal shift, this one is a vertical shift, this one we are shrinking or expanding the graph of f, and then ngati this one lapha ku question 4.1 ngati this is a reflection about the y-axis, ngati this is a reflection about the x-axis, right? So I know Guti, it's easy when you answer these questions because you simply substitute kule function ebakunikele yona, but you must also be able to interpret ukuthi now substitute what are you actually doing to the original function, right? Yeah, into engizama ukuyichaza ngileyo. And then nasichubeka going on to the basic functions, formulas and graphs. Okay, so these are the important terms to remember: domain, range, axis of symmetry, the maximum, the minimum, asymptote, turning point. Domain sengichazile ngathi is the set of possible x values, right? Ngathi nawucabanga ngedomain, think about the x-axis, right? Think about the x-axis, and then mawucabanga nge-range, think about the y-axis, right? A domain is the set of all possible x values, and then the range is the set of all possible y values, right? And then the axis of symmetry, think of an axis of symmetry as a mirror line. It is an imaginary line that divides a graph into two mirror images of each other, right? So if we have a parabola looking like this, then, and when we're cutting this graph into two, this will be the mirror image, because this piece is sort of like a mirror image of this piece, right? Yeah, an axis of symmetry is an imaginary line that divides a graph into two mirror images of each other, right? The maximum of a function, it is the highest possible y value of a function, right? So looking at this graph and wheel, the maximum value of this function, let me pick another example. The maximum value of this function is the highest value, is the highest y value of the function, right? So if I have a graph of the function looking like this, the highest y value is this point here, right? So that is the maximum of the function. The minimum value of this function, it is the lowest point that you can find, right? And then in this case, because this graph goes on to infinity, you won't be able to know the exact minimum value of that function. So you can simply say it is minus infinity, right? In this case, the minimum value is that point. It is the lowest point of the graph. The maximum value, it is the highest possible point you can find. In this case will be infinity, right? The turning point of a graph, okay, asymptote. An asymptote is an imaginary line that a graph approaches but never touches. So I'm sure Guti, you know what an asymptote is from our graphs with hyperbola or exponential graphs, right? So if you have a graph of a hyperbola looking like this, where one piece lies on this quadrant and the other piece lies on this quadrant, right? You have a horizontal asymptote and you have a vertical asymptote, right? Why? Because this graph approaches this line but never touches the line, and it also approaches this line but never touches the line, right? So that is an asymptote. Okay, then we have linear functions or a straight line, right? A linear function has the form of f of x is equals to ax plus q. I always use y is equals to mx plus c, but then it's the same thing. It's just what I prefer. A linear function is in the form y is equals to mx plus c, where m is the value of the gradient and c is the y-intercept, right? So in this case, the value of the gradient is represented by a, and then the y-intercept is q. Y-intercept is where x is equals to 0, right? The graph of y is a straight line. Okay, this graph is a straight line. It has that function y is equals to x, wherever the values of x and y are equal throughout, and then the domain is the set of all possible x values. In this case, the domain is the entire x-axis, and then the range is the entire y-axis, right? Also note, if the value of the gradient is negative, if m is negative, you will have a decreasing function. If m is positive, you'll have an increasing function. And then if m is equals to 0, you'll have a horizontal graph. And then if m is undefined, you'll have a vertical line, right? and then if c is negative, your y-intercept will lie below the x-axis, and then if c is positive, your y-intercept will lie above the x-axis, and then when c is equals to 0, your y-intercept will lie at the origin. Okay, so sketching a linear function. When you sketch a linear function, you have to use the dual intercept method, right? Meaning you have to determine the x-intercept by letting y is equals to 0 and determining the y-intercept by letting x is equals to 0, and then after you plot these 2 points on a graph on the Cartesian plane and connect a straight line through them, right? So if you are given a function in the form y is equals to mx, simply let y is equals to 0 and let x is equals to 0, and then you will have 2 points, and then when you sketch this graph, you just connect those 2 points. Okay, and then determining an equation if you are given a graph, right? If you are given a graph, can you determine an equation? The way to go about it is you need to determine the gradient of the equation, the gradient of the graph or the function, and then you substitute the value of the gradient into the general form, and then you solve for the intercept, right? Okay, let us do examples. I think it will make more sense there. Okay, so we are given the graphs, these straight lines, these 2 straight lines. We want to determine the equation of this graph, right, in the form y is equals to mx plus c, right? So lapha ku number 1, question 1, I have to calculate the gradient by saying y2 minus y1 divided by x2 minus x1, right? I'm picking this point as my x1 and y1 and this point as my x2 and y2, right? So y2 is minus 1 and y1 is minus 0, and y1 is 0, sorry. x2 is 1, and okay, this is my x1, this is my y1, sorry, this is my x2 and this is my y2, this is my x1 and y1, right? So ngenzela ukuthi ngingaphambanisi when I substitute in this equation of the gradient, right? y2 is minus 1, y1 is 0, x2 is 1, and then x1 is 2, right? So here I will have minus 1 over minus 1, I'll have 1, right? And then the next step is to substitute the value of the gradient into my equation. So I will have y is equals to x plus c. The next step is to calculate the value of c. To calculate the value of c, I'll just pick a point, a given point in this graph, and substitute it in this equation. So I'll pick x2 and y2 and substitute into my equation. Okay, so when I pick y2 and x2, I'll wherever I see y here, I'll put minus 1, and then wherever I see x, I'll put 1, right, plus c. Therefore, solving for c, I'll see equal to c is equals to minus 2. So the final equation is x minus 2, right? That is the equation given a graph. Okay, and then siyawela question 2 silandela the same steps. We start by calculating the gradient, right, by saying m is equals to y2 minus y1 divided by x2 minus x1. I'm picking this point, the origin, as my x1 y1, right, and this one is my x2 y2, right. And then when I substitute, I know where I see y2 I put 2, and then where I see y1 I put 0, where I see x2 I put minus 1, and then where I see x1 I put 0. So the gradient is minus 2. So now I have the gradient, I have to substitute it in my equation. So I'll have y is equals to minus 2x plus c, right. Notice the graph cuts through the origin. So looking at the graph, already I know the value of c is 0, because that is the y-intercept, right. The graph cuts through at the origin, so the y-intercept has to be 0, right. But then if you want to calculate it, you can simply use that point. You can simply substitute using that point, x2 and y2, right. Where you see y, you'll put 2, and then where you see x, you'll put minus 1, right. And then solving for solving for c, you'll see at the end c is equals to 0, right. Therefore our equation is just y is equals to minus 2x. Okay, right. And then now going on to quadratic functions, the parabola. So a quadratic function is a parabola and can be represented with the general form of y is equals to x squared plus bx plus c, or y is equals to ax plus p squared plus q, right. So a parabola is a function in the form y is equals to, a quadratic function is a function in this form, y is equals to ax squared plus bx plus c, or y is equals to ax minus p squared plus q. For some reason, I prefer to put minus p here instead of plus p. So yeah, so in this case, like, if maybe I'm given a function, let's say 2x minus 1 squared plus 3. If it's given like this, I know okay, so I think the reason why I prefer putting minus p here is I know when the quadratic function is given in this form, I know the coordinates of the turning point will be p, q, right. So I won't be confused if I'm given a function like in this form. If it's in this form, I know the turning point will be 1 and 3. The coordinates of the turning point, it's x is 1 and y is 3. That's just how I see it. But then if you prefer using plus q is fine, but mina kuma examples esizowenza izosebenzisa minus p, right. So lokho kwenzela ukuthi mina ngingabi confused, right. Okay, so a quadratic function is a function in the form y is equals to ax squared plus bx plus c, where c is the y-intercept, right. And then it can also be given in this form: y is equals to a times x minus p squared plus q, right. So from this, if you have a function given in this form, the way to calculate the turning point, you'll say x is equals to minus b over 2a, right? That will be the x coordinate of the turning point, and the y coordinate of the turning point, you will substitute this x value into your equation to get the corresponding y value, right? And then if it's given like this, you know straight away with the coordinates of the turning point is p and q. Okay, those are just some of the highlights, right? Okay, so a quadratic function is a parabola and can be represented with this general formula: y is equals to ax squared plus bx plus c, or y is equals to a times x plus p squared plus q. So if the value of a is negative, we have a sad function, and if the value of a is positive, we have a happy function, right? The graph has an axis of symmetry at x is equals to minus b over 2a, and then to get the y coordinate of the turning point, you'll substitute x is equals to minus b over 2a in your function. So the function may have either a maximum or a minimum value, but not both. So usually the minimum value will be the turning point, and the maximum value, the minimum values and the maximum values will usually be the turning points, right? So the domain of the function is the entire x-axis, and the range is, okay, let us try to visualize the domain and range of a quadratic function. So the domain, let us say our graph looks like this, right? Our graph looks like this. Notice ukuthi this graph, because it goes on to positive infinity, notice ukuthi this graph exists for all values of x, right? If you draw vertical lines, multiple vertical lines, they will intersect the graph they will intersect the graph at some point if you draw multiple vertical lines. So it means the domain is the entire x-axis. That's why x is an element of the real numbers is our domain, right? But then for a range, our graph looks like this. For a range, you just draw multiple vertical lines, horizontal lines, right? And then you'll see what they intersect the graph up until this point, right? But then when you go below the x-axis, you see what they don't intersect the graph anywhere. So it means our range, the graph exists from this point going up, right? So our range will be y is greater or equals to this point. In this case, this point is 0, right? The y coordinate there is 0. So in this case, the range will say the range is y greater or equals to 0, or in this form, y is an element of 0 to infinity. That is our range. Remember, when you think about the range, think about the y-axis, right? The graph exists from okay, when you think about the range, we think about the y-axis, right? And then drawing vertical horizontal lines, they only cross the graph up until this point. It means the graph exists from here going up, but then below the x-axis it doesn't exist. So that's why we say our range is y is greater than 0, right? If the graph looks like this, x, the domain is still x is an element of real numbers, because when you draw multiple vertical lines, they will cross the graph at some point, right? But then when you draw multiple horizontal lines, they will only cross the graph below the x-axis, but then above the x-axis they won't be crossing anything. So in this case the range will be all the y values less than or equals to 0. So the range will be y is less than or equals to 0, right? Or am I in this form? So the range is y is less than or equals to 0, or the range is an y element of y is an element of 0, sorry, y is an element of minus infinity to 0. Y is an element of minus infinity to 0, right? Yeah, that is the range. So sketching the quadratic function. When you sketch the quadratic function, these are the steps to follow. You need to write down the intercept by letting y is equals to 0, and then you need to calculate the x-intercepts. You need to write down the y-intercept by letting x is equals to 0. You need to calculate the x-intercepts by letting y equals to 0 and solving for x. And then to determine the axis of symmetry, you need to calculate the x value of the turning point, and then after getting that x value, you substitute it into your equation to get the corresponding y value, and then you will have your coordinates of the turning point. And then after, you sort of plot the points and draw a line connecting all the dots. Okay, so let us do an example. So we have to sketch the graph of this function, right? We have to sketch the graph of this function. We have to sketch the graph of this function. X squared, f of x is equals to x squared minus 5x minus 6, right? Notice that this function is given in the form y is equals to ax squared plus bx plus c, where a is equals to 1, therefore a is greater than 0. We know that's the shape. And then b is equals to minus 5, c is equals to minus 6, right? So to sketch the function, we need to calculate the y-intercept. Y-intercept, right? We let x be 0, and then we substitute in our function. So we'll have f of 0 is equals to minus 6. So the point of the y-intercept is 0, minus 6, right? And then we have to calculate the x-intercept. X-intercept, we let y be 0, and then you will solve for x, right? When we let y be 0, we mean let f of x be 0, right? F of x is x squared minus 5x minus 6 equals to 0, and then we just solve for x from here, right? Factorizing this our solution, right? X is equals to 6, or x is equals to minus 1. Therefore the coordinates of the x-intercepts is minus 1, 0, and 6, 0, right? Now I have to calculate the turning point, right? The turning point to kumbulunte x is equals to minus b over 2a, right? And then you substitute b, the value of b is minus 5, so here you will have minus 5, and then here you will have 2a, a is 1, so the turning point is 5/2, the x value of the turning point, and then the y value of the turning point is f of 5/2, and then when we see x in our function we put 5/2, we'll have 5/2 squared minus 5 times 5/2 minus 6. We will get, just punching this into my calculator, 5/2 squared minus 5 times 5/2 minus 6. This is negative 49/4. This is negative 49/4, or we can just say it's negative 12 1/4, right? So now we have all our points, right? So our turning point, the coordinates of the turning point is 5/2 minus 12 1/4, right? Minus 12.25. Right, now we have all our points. We simply need to plot them and then connect the dots, right? So we have a Cartesian plane, right? We have the x-axis, and then here we'll have the y-axis, right? This is the y-axis, and then our y-intercept, we said it's -6. So if -6 is somewhere here, this will be our point, right? And then our x-intercept, we said it's -1 and 6. So if -1 will be somewhere here, this will be our point, right? And then 6 will be somewhere there, this will be our point, right? And then our x value of the turning point is 5/2, which is sort of like 2.5. So 2.5 will be somewhere there. This will be our axis of symmetry. 2.5 will be somewhere there, will be our axis of symmetry, right? And then the y value of the turning point is -12.25, which is somewhere there. Will be -12 1/4, will be somewhere here. So this will be our coordinate of the turning point, and then now we have to connect the dots with a line, right? Okay, for me it's difficult to draw smoothly in this on the screen, so yeah, that's why graph yami chekile. Okay, oops, yeah, it's really difficult to draw like screening. Okay, so our graph will look like this. I know mine is not perfect, but yeah, this is the picture. This will be our graph. So these are the steps to follow when you want to sketch a quadratic function. First, your y-intercept, you let x is equals to 0, and then you'll get your y-intercept. X-intercepts, y-intercept let x0, and then x-intercept let y0, and then you just solve for x to get your coordinates of the x-intercept. Your turning point, you use this equation for x is equals to minus b over 2a, and then you substitute these values into this equation, and then you get your x value. After getting that x value, you substitute it in the equation to get this y value, and then now you'll have your points. Then after you plot them on a Cartesian plane and connect with a line, you'll have your parabola, and then you'll be done. Okay, so yeah, these are the steps to follow. This is the graph, and then now so you'll sort of have like two cases with functions and graph, right? You'll have maybe a function and then you need to sketch a graph, or you'll have the equation and then you'll need, sorry, the first case you have an equation, you need to sketch the graph. The second case is you are given a graph and then you need to come up with an equation. So these are the scenarios when you are given a graph and then need to determine the equation. So if you are given 3 x-intercepts and 1 point, use the formula y is equals to a x minus x1 times x minus x2, and then substitute the values of the intercepts into this equation, right? So x1 will be your first x-intercept, x2 will be your second x-intercept, and then substitute them there, and then after you sort of like expand and use some other point that will be given to solve for a, and then you'll come up with your equation. The second case, when you are given a turning point, you will have to use the graph. You'll have to use the function, the quadratic function in this form of y is equals to a times x plus p squared plus q, right? And then pq will be your turning point, and then you substitute the other point that is given to calculate the value of a, right? And then you'll have your equation, right? The other case is when you are given the coordinates of 3 points on the parabola, one of them being the y-intercept. You will use the standard formula or the standard form of the quadratic function, and then the other point, which is the y-intercept, will determine the value of c. So after having that value of c, you'll use the other 2 points that are not the y-intercept to solve for a and b using simultaneous equations. Okay, so let us do activity 2, and let us do activity 2. Okay, so allow activity 2, but the sketch represents a graph of the parabola given by that function. Points A, B, and C are the intercept on the axis, and D is the turning point of the graph, right? Question 1.1, but determine the coordinates of A, B, and C, right? Looking at the graph, I can determine the coordinates of B because B represents the y-intercept of the graph, and then I know what the function has been given in the form of f of x is equals to ax squared plus bx plus c, where c is the value of the y-intercept. In this case, c is 2. So the coordinates of b is x is equals to 0, y is 2. That's 1.1. And then the coordinates of a and c are the x-intercepts, right? So now those are the x-intercepts. So now to calculate the x-intercept, you need to let y be 0, right? And then when you let y be 0, you are just letting f of x be 0, and then you just need to solve for x, right? X minus x squared equals to 0. So x is equals to minus b plus of minus the square root of b squared minus 4ac, b squared minus 4ac divided by 2a minus b minus b, in this case is minus 1, plus of minus 1 squared, minus 4a is minus 1, c is 2, right, divided by 2a, which is minus 1, right? So x is equals to, substituting in my calculator, 1 plus minus 4ac, x is equals to minus 2, or x is equals to x is equals to 1, right? So the coordinates of a will be minus 2, 0, and the coordinates of c will be 1, 0. Okay, and then 1.2, but it determines the coordinates of the turning point. So state the coordinates of the turning point. We have to calculate the x coordinate, the x value, by saying minus b over 2a, and then b is minus 1, we just substitute minus 1 where we see b, and then a is also minus 1, we substitute minus 1 where we see a. So there we'll have minus 1 over 2, and then substituting minus 1 over 2 in our function, we get that the y value will be 2 minus, the y value will be 9 over 4. The y value will be 9 over 4, right? So the coordinates of d will be minus 1 over 2, 9 over 4, right? And then 1.3, but write down the equation of the axis of symmetry of x minus of f of x minus 5, right? Now this is where the first activity that we did comes in. Remember, until you should be able to interpret ukuthi when you are sort of like substituting values like this in your function, you are transforming the original function in a way, and then ngati in a case like this, maybe where you say f of x plus a, you are shifting the original function horizontally by a units, either to the left or to the right. So now to determine the equation of the axis of symmetry of f of x minus 5, I need to know what is the equation of symmetry of f of x. The equation of symmetry of f of x is x equals to 1 over 2. We calculated it here, that is the x coordinate of the turning point. So the equation of the axis of symmetry of f of x minus 5 will be x is equals to minus 1 over 2 plus 5, because I'm shifting this 5 units, I'm shifting the graph of f 5 units to the right, right? So it will be 9 over 2, x will be 9 over 2, will be the equation of the axis of symmetry for this function, right? So now if maybe I wanted to determine the axis of symmetry for f of x plus 5, I will be shifting this graph 5 units to the left, then my axis of symmetry there will be minus 1 over 2 minus 5, right, which will be minus 11 over 2, right, minus 11 over 2. But then now we are shifting this whole function to the right, 5 units to the right. Okay, and then now they want us to determine the values 1.4 determine the values of x for which minus f of x is greater than 0, right? So when you are saying minus f of x, you are reflecting the original function about the x-axis, right? So minus f of x, you are shifting the original function about the x-axis. So the values of x for which f of x is greater than 0 are the same values of x for which, the values of x for which minus f of x is greater than 0 are the same values of x for which f of x is less than 0. I don't know if that makes sense. So if I'm reflecting this function about the x-axis, it will look like this, right? It will look like this. So there I wanted the values of x for which the function, I don't think this is true. Okay, so minus f of x is the reflection of this function about the x-axis. It will look like this after I reflected it. It will look like this after reflection, right? And then now the values of x for which this function is greater than 0 is this point here going to the right and this point here going to the left. So the values of x for which that function is greater than 0 will be x is less than or equals to minus 2, or x is greater or equals to 1. Yeah, so those are the values. I hope it makes sense. If it doesn't, don't hesitate to ask me where you don't understand. Remember guys, this is your final lab towards your final exams. This is your final preparations. I'm here to assist. So if ungazwisisi, ungasaba ukungibuza, I'm more than happy to explain once more la ungazwisisi khona. Khumbula ukuthi this section, it contributes a lot to paper 1 yama functions and graphs. So I know ukuthi lapho kunye sort of like in explaining a speed ngenze ukuthi awangizwa. So if that's the case, don't hesitate to ask. Ungitshela ukuthi kuphi la ungazwisisi khona, so ngingazama ukuthi ngichazele ngona, right? Yeah, I think that will be it for this video.